Thanks. So, as Elise said, I'm here to talk about looking glasses. And so we're going to cover a few things in this talk. First, what is a looking glass? And then how do you use them? And then what types of data can looking glasses show you? And why would you use them? Why would you want to look at any of that data? Then I'm going to go into talk a bit about the packet clearinghouse looking glasses, because those are my looking glass project and why I'm interested in the topic. And then at the end, a little bit on how to set up your own if you're interested in that. So a looking glass is usually a web page, but sometimes just a router that you can log into that allows you to look at the routing information of some other network. So this can allow you to see routing information from various vantage points. And generally, you can either do, most of the web pages allow you to do some subset of the show IP BGP commands, and some of the ones that are routers that you can log into let you look at pretty much everything. For the looking glasses that you can telnet to, the example of that I think a lot of you are familiar with is the routeviews server, which is routeviews.org and ix.net, and I think it's also routeviews.org now. And that one just takes standard Cisco show IP BGP commands. And then most of the looking glasses out there are web pages now, so are CGI programs. So as I said, that specifies what commands you can use, and this is a lot more user-friendly if you aren't really up on your show IP BGP syntax, and network operators tend to find it less scary because they can limit what commands people are going to be running. So this is a screenshot of the routeviews looking glass. So as you can see, that's standard Cisco router, and you can give it routing queries. And this is the PCH looking glass. So that's a web page where you tell it what query you want to do and give it any arguments you want to give it, and tell it what router you want to go query, and then it does it for you. So there are a bunch of different types of data that get used in looking glasses. So a lot of them, I think most of them out there, are full routes from one network. So you can use one of these to figure out what your network looks like from one other network's perspective, or if you want to know why that network's users can't get to you, you can look and see if they have routes back to you. Or it doesn't have to be your network that you're doing these queries for. It could be some other random network that you're curious about. The historical example of this sort of thing was nitrous.digex.net, which gave views of digex's routing tables at a bunch of exchange points, and I don't think that one exists anymore. And then there are looking glasses that take full routes from many networks, which is what the routeviews project does. So this is basically a variation on the full routes from one network theme, but it's just a lot more data in one place. So if you're if you want to see if a route is being generally visible on the internet, you can go to routeviews or something like that and look through and see a whole bunch of data from a whole bunch of different networks all right there. But the limitation on this is generally each network that peers with a looking glass like that gives only its best route to the destination. So you'll see what's seen as the best route, but you won't see all the possible paths to get somewhere. And then there are the special purpose looking glasses, which are designed to show some specific type of information. So I'll talk more about the PCH one later, but on ours we only collect peering routes, and we use it to show what peering routes are available where. There's a commercial service from Renesys, which is at www.renesys.com, which is sort of a looking glass, and they do neat visual maps of AS path trees, so you can actually get a map of this is how the network branches out from the points where they're looking at it. And they also look at every BGP announcement and withdrawal that they see as it happens, and they archive them. So you can, if you're a customer of theirs, they can alert you on whether you're whether one of your routes is flapping, or you can go look at the history of a given route over the last several years and see how many times it's been announced and withdrawn and from where and so forth. And Todd Underwood from Renesas does a lot of presentations on this that I'm sure you can Google for. I'm not sure if he's presented at NANOG or not, but Susan's saying he has. So they must be in the NANOG archives as well. So there's a lot more detail on that there. And RIPE runs their RIS project, which is combination looking glass, and also does recordings of announcements and withdrawals, and kind of like Renesas does. And they don't have nearly as nice of an interface, but they're free, so that's always somewhat of an advantage. And so if you want to find some of these looking glasses, there are, first of all, if you're looking for information on routing information from a specific network, probably the easiest way to figure out whether they've got a looking glass is to call up the network you're wondering about and ask them, or ask people at NANOG who work for them. There's also a couple of big lists that are being maintained, one of which is at www.traceroute.org, and then there's the Looking Glass wiki at www.bgp4.net. And okay, so why would you want to use one of these? First of all, when you change routing announcements, it's always good to know whether your routes are actually propagating out onto the net before your customers start complaining and going, "Hi, ever since your maintenance window, I haven't been able to get to you." So you can check looking glasses in a variety of places to see if your routing announcements have gotten out. So if your upstream provider has a looking glass, that's really useful, because you can go there and see, are they seeing your routes? Because if they aren't seeing your routes, then probably nobody else will. And you can check other looking glasses and make sure that your routes are visible. And the big one that I always check whenever I make changes is go to route views and look and see whether Vareo is seeing the routes, because Vareo does, I think, more strict RADB-based filtering than anybody else big. So whether Vareo is seeing your routes is a good indication of whether your RADB filtering is working correctly. And the other thing is, if you want to look at, after making changes, you want to know whether you've flapped enough that networks will start dampening your routes. So if the looking glasses are showing you as having flapped a bunch of times, that's a good sign, or that's a good indication that other networks probably will have seen that too. And in the same vein, it's also useful for troubleshooting routing issues. So if people start complaining that they can't get to your network and you don't think you've made any changes, it's still often useful to go look and see whether the rest of your network is being seen, or see whether your routes are being seen by the rest of the network. As something may have gone wrong with your announcements that you don't know about, somebody may have, or your upstream providers may have made a filtering change that you weren't aware of or didn't realize what its impact was going to be. And also, if you're getting complaints from some places that you can't reproduce, then it's good to be able to look around and see, does everybody have a consistent view of your network? Because if part of the internet is seeing one thing and part of the internet is seeing the other thing, then that would be a good reason why, if all your test points are on the side of the internet that is seeing things the way you want it to be seen, then that would be why you can't reproduce the problem. And another useful thing to be able to look at is if you're considering buying transit from somebody. You can look and see how well connected their network is, and this will tell you, what you're likely to get by pairing with them or buying transit from them. So if you start looking around and everybody's path into a given network looks the same, comes through the same AS above them, that's a pretty good indication that they're probably single-homed, and that may not be what you're looking for. On the other hand, maximum diversity is not always optimal, so that's not a subject to go into here, but just a disclaimer. And if you're looking at how well connected a network is, you can also sometimes look and see whether, do the ASs between this point and this point make some amount of geographic sense. So if you're trying to get from, somewhere in, say, Bangladesh to somewhere else in Bangladesh, and all the paths that you're seeing go through North America, that's an indication that you're going to get a lot of latency. And perhaps not, perhaps reliability problems as well. You can't always tell this sort of thing just from BGP tables, though, because a lot of networks do, a lot of ASs do have a fairly big geographic spread. So now I want to talk a little bit about the looking glasses that I run and what our goals are there. And we keep getting asked, aren't there enough route collectors already? Why aren't, why are you guys running yet another one? And I guess the answer that everybody tries to give to that sort of question is, because we're doing something different. So that's my answer too. We're running a route collection network. So we've got looking glasses in a whole bunch of different exchange points, and we're collecting peering data. So we're attempting to show what data you can get by peering in various places. So this we're hoping is useful for network planning and research, but probably not so useful for troubleshooting, because since we're not showing full tables, if a route isn't in our routing table, that doesn't actually mean it's not reachable. So we've got our looking glasses in roughly 30 exchange points right now, although not all of them are fully turned up, and we've got about 300 peering sessions with 200 different ASs, so it's a fair amount of data, but we're still working on increasing that. And what we're trying to use this for are both network mappings, trying to figure out what networks are connected where and what networks are in what parts of the world, and also for doing some traffic and peering analysis. So if we're trying to analyze, how much of a network's traffic could be gotten could be offloaded to peering, and all we've got is somebody's full routing table, we see only what they see as the best paths. So we're trying to collect all the paths that would be visible at an exchange point by peering with various different networks, so that we can get a more accurate picture of that sort of thing. And our data is not nearly complete. We peer only with those who will peer with us, and there are a number of objections we hear to when we ask for peering that I suspect a lot of other looking glass operators who are trying to get more than just their own data here as well, which is, well, we already see you through transit, why should we peer with you? And we don't have much traffic going to you, which are sort of beside the point for route collection or looking glass operations, because traffic isn't what we're peering for. But again, that's other networks' peering policies, so that's their choice. And maybe this is okay, because if we're collecting routes from those who peer openly, maybe that's the same stuff that's going to be available to at least other small providers who are interested in getting into peering. So if you want to look at our data, we've got the real-time looking glass at lg.pch.net, and we're also archiving daily snapshots of routing tables from these exchange points at archive.pch.net. And that archive server actually isn't working very well right now, because it's too many flat text files and is more than bigger directories than the server can handle. So we're working on getting that into a database, and it should be a lot more usable. So my sort of shameless plug here, and my plea to those of you who are making peering decisions, is please peer with us so that we can get more data into our looking glass and hopefully share more data with the rest of the community. Since we don't ask for anything other than your peering routes, you can treat us like any other peer and just do whatever you normally do to turn up a peering session. And we also run an Anycast DNS network, which gives access to a bunch of top-level domains, so that can help improve your network reliability. But anyway, so how do we operate this? And this is 5 minutes? Okay. And this is perhaps useful if you're interested in running your own looking glass. We use Cisco 1760s as the route collectors, which are their little 1U boxes. They only pass about 20 megs of traffic, but if all we're trying to do is collect routes, traffic throughput doesn't matter that much. And the nice thing about the 1760s is they hold 192 megabytes of memory. So, even if you're holding, so they'll hold full tables very nicely. And we do a 4U standard package that, I guess 1U of which is the Anycast, or is the looking glass router, and then the other three use, the Anycast installation. So we're always looking for more exchange points to put that into. And then we peer with every network that's willing to peer with us, basically by doing the standard peering coordinator things, sending out email, talking to people at conferences, and so forth. And as I said, we take only peering routes. The software we run is a slightly modified version of the rancid Looking Glass, and it's a CGI program that we're currently running in only one location, but we're looking at anycasting it just to get that web page closer to the end users. So if you want to do your own Looking Glass server, you can either use a standalone route collector that peers with something in your network and gets what you see as the best routes, or you can point the Looking Glass software at a production router. So if you're doing a standalone route collector, I can highly recommend the 1760. It works very nicely for us, but a Zebra or Quagga box would give you more flexibility at the cost of having a PC or something like that to maintain. You can also point Looking Glass, and as I said, you can also point the Looking Glass software to a production router, and then that gets rid of the need to have a route collector. Looking Glass, there are a bunch of different CGI programs you can use for the web end of the Looking Glass. The rancid software that we run is at www.shrubbery.net. Traceroute.org has a good list of other Looking Glass packages. And the CGI on the web server is going to need access to log into the router that you're looking at the routing tables of, because it needs to be able to get that data somehow. So thanks.
Do we have any questions for Steve about the Looking Glass? Okay, here comes a question. Walt? If our other speakers could start making their way to the stage, please.
Quick question. I'm Walt Peru from Los Netos. Okay. Why do you do what you're doing? Do you get any money for doing this?
We get a bit of grant money for it. It also ties into a lot of, we're doing a lot of work on exchange point construction in developing countries, and it helps us measure what's out there and show what some of the effects of the exchange point stuff that we're doing is.
Okay, well, thank you very much.